Hello, Year 10s. I'm going to try to come in and teach you one day this week, but I wasn't able to come in today to teach you, so I'm just made this little pre-recorded lesson for you on quadratic sequences. So that's your title for today. It says start on a whiteboard, but honestly, you can do this wherever you would like. Ideally, maybe even in your exercise book is absolutely fine. Could you go ahead and find the nth term of this linear sequence for me? So we talked about linear sequences last time I saw you, which was now a while ago. And then could you also find the 20th term? And then after you've done that, you've got the nth term of a sequence is given as 2n take away 5. I would like you to try to find the difference between the 10th term and the second term. So if you want to pause this and leave it up on the board and then press play in just a moment, I'll go through the answers. All right, here we go. Find the nth term of this linear sequence. So first we want to find out how much it's going up by. So it looks to get from 35 to 42, that's going to be add 7. 42 to 49, still add 7. So this is going up by 7 every time. So I want to compare this to the 7 times table. 7, 14, 21, 28. And I can go ahead and subtract those. And I'm going to end up with 28, 28, 28, and 28. So this looks like it is the 7 times table plus 28 more. So if I want to find the 20th term, it's going to be 7 times by 20 plus 28, which is 140 plus 28. So we're looking for 168. The next question, totally different sequence, is given by 2n take away 5. Find the difference between the 10th term and the second term. Well, the 10th term is going to be 2 times by 10 take away 5, which is going to give us 15. And then the second term is going to be 2 times by 2 take away 5, which is going to give us -1. So the difference between those two, 15 take away -1, is going to give us 16. So there's our final answer. So that was just a little check on whether or not we could use linear sequences. Now we're going to go on and talk about our quadratic sequences. So the plan for this lesson is going to be able to show that something is a quadratic sequence. It's really simple to do. You just need to do 2 subtractions, really. And then we're going to try to find the second difference, which is the main thing for today. And then if we can do that, and we can find the nth term of a linear sequence, we should be able to find the nth term of a nice, simple quadratic sequence. Those are going to be up to grade 7. It's technically like an easy grade 7, but still a grade 7 nonetheless. It's going to be very similar to how we found the nth term of a linear sequence. I just have one extra thing to tell you about instead today. All right, let's talk about what a second difference is. So quadratic sequences are defined as a sequence that has the same second difference. Now you might be thinking, what is a second difference? Well, when we figured out which times table was in our linear sequences, we were doing that by finding the first differences. I'm going to tell you the most simple set of quadratic sequence numbers that you can ever think of, and quadratic sequences are always given as something squared. So quadratic sequences are about having a square in them. And if we think about the most simple square numbers that we can, let's think about the actual square numbers. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So those are the set of n squared numbers. These are the square numbers that we know. What we're going to do is we're going to find the first difference. So how much do we need to get from 1 to 4? That's going to be 3. 4 to 9, that's 5. 9 to 16, that's 7. And 16 to 25, that is 9. So obviously those are going up by a different amount every single time. Those numbers that I wrote in red, those are called the first differences because I'm finding the differences between the numbers the first time. And then if I find the difference of these red numbers from 3 to 5, that's 2. From 5 to 7, that's also 2. And from 7 to 9, that's also 2. So those blue numbers, they're called the second difference. And as you can see, they're all the same number. They're all 2. The red numbers were the first difference, and they made a pattern. That's the main thing you need to know about quadratic sequences. The next slide, I'm going to try to explain to you the difference between all the different kinds of quadratic numbers we can have. That doesn't really make any sense, but basically when we were looking at our linear sequences, we looked at what was our difference and we knew what kind of times table to compare our sequences to. Quadratic sequences tell us well, we're going to find out what kind of quadratic sequence we're going to compare things to. So there's so many things I could be telling you right now. Let's just listen on the next slide and hopefully I'll make some sense. Okay, so here we've got 4 different quadratic sequences, and I've explained on each of them how we get these quadratic sequence numbers as well. So the first set of numbers on the top left, 1, 4, 9, 16, and 25, those we get by just taking the square numbers. It says take n and square them. So that's 1 squared, 2 squared, 3 squared, and so on. That's all they're looking for. Those numbers right there are the n squared numbers, or the square numbers. And if we go ahead, well, we've already done this about 10 seconds ago, we can find the second differences of these quadratic sequences. So we've already said this is 3, 5, 7, and 9 for the first differences, and then the second differences are 2, 2, and 2. Now I'm going to keep all that on the board. I'm going to try to do this in different colors so we can see the difference between all of them. But the second difference of n squared was 2. Let's look at what happens if we have 2n squared. So all we're doing is we're taking these numbers 1, 4, 9, 16, and 25, and to get to our next set of numbers, we're timesing them by 2, because we're doing 2n squared, which if we think about how we write that in maths, that's just 2 times by n squared. So all that wants us to do is take all of our n squared numbers and double them. So let's go ahead and find our first differences, 6, 10, 14, 18, and now our second differences are 4, 4, and 4. Now when we had a second difference of 4, that was generated when we had 2n squared. That is not a coincidence. Let's look down at the bottom left. We've got 3n squared. And where did these numbers 3, 12, 27, 48, and 25 come from? Well, those are the n squared numbers times by 3, because we're looking for 3n squared, which is just 3 times by n squared. Let's try to make this green pen a little bit darker. All right, there we go. So let's try to find our first and second differences. We've got 9, 15, 21, and 27. And if we find our second differences, 6, 6, and 6. Okay, so this time we had a different second difference. We had a second difference of 6, and that was related to 3n squared. So we had a second difference of 6, and that told us it was going to be 3n squared. I don't know if you're noticing a pattern. Hopefully maybe you are. Let's try to get one more color, and we'll do this again. We'll do it in, it's going to have to be black ink, sorry. All right, next we've got 4n squared. So let's find the first differences, 12, 20, 36, and, oh, that's not 36, hang on. 28, sorry, and 36. All right, let's find the next differences. The second differences, we've got 8, 8, and 8. So this time our second difference of 8 gave us 4n squared. Are you noticing any pattern? I don't know if you are. I'm going to go ahead and tell you in case you haven't noticed. So when we got a second difference of 2, that told us that we were looking for just n squared. So if we had a second difference of 2, 2 divided by 2 gives us 1. That tells us we're looking for 1n squared. But we don't normally call it 1n squared. We just call it n squared. And next up we had a second difference of 4. Well, 4 divided by 2 gives us 2. That tells us we're looking to compare it to 2n squared. Then we had a second difference of 6. 6 divided by 2 is 3. That told us to compare it with 3n squared. And then lastly, we had a second difference of 8. 8 divided by 2 is going to give us 4. We need to compare it with 4n squared. So what we always want to do is take our second difference and divide it by 2. All right, that was a long time of me talking about almost nothing, it feels like. I'm going to go through an example. I just want you to listen. I don't want you to write down anything at all. I'm just going to go through how we find the nth term of a quadratic sequence. Just listen to it. Then you can write one down, and then you can try one in your book. All right, let's do this. All right, so pretty standard. Find the nth term of this quadratic sequence. So we're going to go ahead and we're going to find the first and second differences. So from 7 to 13 is 6, 13 to 23 is 10, 23 to 37 is 14, and 37 to 55 is 18. There's our first differences. Now we have to find our second differences. 6 to 10 is 4, 10 to 14 is 4, and 14 to 18 is also 4. So our second difference of 4 divided by 2, it's going to give us 2. We are interested in comparing this with 2n squared. Now you might be wondering, normally everybody does, Miss, where do we get 2n squared from? Well, here's how we get our squared numbers, n squared. I would definitely recommend writing this down in like the column of your margin in your exercise book. I always write this down on like the right or left hand side of my page when I'm doing this as a question. So n squared, the n squared numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. We want to compare this to 2n squared. So how do we get from n squared to 2n squared? We double everything. 2, 8, 18, 32, and 50. So now I want to compare my 7, 13, 23, 37, and 55 with my 2n squared numbers. 2, 8, 18, 32, and 50. Just like when I was doing linear sequences and I said, oh, it's the 4 times table, I did my 4 times table underneath and then I subtracted. Same idea today. It's just we're deciding which set of square numbers they're like, and then we're going to compare them. 7 take away 2 is 5. 13 take away 8, still 5. 23 take away 18, still 5. So we've got two really, really important things here. We know we are looking at 2n squared. That's super important. And then we know that this is always 5 more than that. So 2n squared plus 5. So it's literally the same thing as our linear sequences. We just have to figure out which set of quadratic numbers to compare it with. All right, I'm going to go through this one more time. I want you to write the next one in your exercise book. All right, next example. Find the nth term of the quadratic sequence. You don't even need to write those down. You're just interested in these numbers. 10, 16, 26, 40, and 58. All right, maybe take a pause if you need to. 10, 16, 26, 40, and 58. Let's make sure we've written those down in our book. Okay, then we're going to find our first and second terms. Our first and second differences. If you don't want to be taking up lots of space, you can write down your first and second differences on top of the sequence instead of underneath. So 10 to 16 is 6, 16 to 26 is 10, 26 to 40 is 14, and 14 to 58 is 18. So there's my first differences. They're all different. And now I'm going to find my second differences. 4, 4, and 4. Okay, second difference of 4, that tells me right away that I am interested in comparing this to 2n squared. 4 divided by 2 is 2, so that's where I got my 2n squared from. What are the 2n squared numbers? Great question. All right, well, let's see. Here's my n squared numbers. 1, 4. Actually, you know what? Let's write these somewhere else. They're looking a little bit bunched up over there. I'm going to write this down here. My n squared numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. There's my n squared numbers. I want to find 2n squared. So I'm going to go ahead and double all of those. 2, 8, 18, 32, and 50. Now I'm going to see if I can try to fit this all in without having to write the sequence again, because typically my classes have been saying, oh, miss, it takes too much time to rewrite everything. So now I'm going to compare my sequence 10, 16, 26, 40, and 58 with those blue numbers that I just wrote down. 2, 8, 18, 32, and 50. Okay, I'm going to go ahead and subtract those. 10 take away 2 is 8. 16 take away 8 is 8. 26 take away 8 is 8. 26 take away 18 is 8. And all of these subtractions are going to give me 8. So there's two really important things here. My 2n squared and then my difference of 8. So my nth term is 2n squared plus 8. Okay, perhaps we should pause here, make sure we've all got that written down. And then I'm going to get you to try the next question by yourself. Okay. Conveniently, both of these have been a second difference of 4, which told us we were going to compare everything to 2n squared. The only thing that we would do different, if we got a second difference of 6, that would just mean we're going to compare it with 3n squared. Everything else stays exactly the same. All right, let's see what the next question is going to be. All right, here's your next example. I'll read it out to you, and then I would definitely recommend that we take a pause so you can try it either on a whiteboard or in your exercise book, and then we'll see where we go from there. So find the nth term of the quadratic sequence: 8, 17, 32, 53, and 80. Go ahead and take a pause, and then I'll be right back to play the answer for you. All right, so we have to start out by finding our first differences: 9, 15, 21, 27. So let's go ahead and find our second differences: 6, 6, 6. So those second differences tell us we're going to compare this to 3n squared. But how do we find 3n squared? Well, firstly, I'm going to find my n squared numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So 3n squared must be all those numbers times by 3. 3, 12, 27, 48, 75. So I'm going to rewrite this because I wrote my second differences underneath. 8, 17, 32, 53, and 80. And I'm going to subtract off 3, 12, 27, 48, and 75. So what happens when I subtract those? 5, 5, 5, 5, and 5. Okay, I want to make sure that all those numbers are consistent. So two really important pieces of information: 3n squared, add 5. There we go. 3n squared, add 5. All right, let's try another one. Okay, same thing again. Let's have another go at this. I'll read it out to you, then take a pause, and then listen for the answer. Find the nth term of this quadratic sequence: 7, 19, 39, 67, 103. Okay, whether you're writing that on your whiteboard or in your exercise book, I don't mind. I just want you to have another go at it. Go ahead and pause the video. All right, here is our answer. Let's find those first differences: 12, 20, 28, and 36. And our second differences: 8, 8, and 8. So that time we're looking to compare this to 4n squared. What are the 4n squared numbers? I'm not sure, but n squared is 1, 4, 9, 16, and 25. So 4n squared must be all of those times by 4. 4, 16, 36, 64, and 100. So let's go ahead and compare those. 4, 16, 36, 64. All right, I can already start to see that those are definitely just 3 more than, so I'm not going to go ahead and even worry about the 100. If you can definitely notice the pattern, don't panic if you don't want to write down all 5 numbers. So now I'm going to go ahead and subtract this. That gives me 3, 3, 3, 3. Obviously, 103 take away 100 is still going to give me 3, which is why I couldn't really be bothered with that one. All right, so I've got my 4n squared and then my positive 3. So 4n squared plus 3. Obviously, if when I subtracted these were all negative. They're not, but I'm just saying if they were, then my answer would be 4n squared minus 3. So that's just a for instance. All right, I'm going to do one more example just in case you're like, what is she going on about? And then other than that, I'm going to get you to practice some of these questions now. All right, this is the last example from me, exactly the same idea. So if you want, definitely, I'll read out the numbers and then you go ahead and pause this. So find the nth term of this quadratic sequence: -2, 4, 14, 28, and 46. All right, here we go. So we've got 6, 10, 14, and 18. And our second difference is 4, 4, and 4. So I'm going to compare this with 2n squared. My n squared numbers: 1, 4, 9, 16, 25. And 2n squared is all of those doubled: 2, 8, 18, 32, and 50. All right, 2, 8, 18, 32. I can see the pattern. Let's subtract this. So this first answer right here is going to be -2, take away 2, which is -4. This next answer is going to be 4 take away 8, which is also negative 4. 14 take away 18, also negative 4. That pattern is going to continue, so we are interested in 2n squared and negative 4. 2n squared, take away 4. All right, hopefully that's making some sort of sense. I definitely want you to practice that now. I've got lots of examples on the next slide. When I did it with the set 2 class, they took about 20 minutes to get the questions done. We didn't all do all of them, but there's definitely a good place to start. You can either pause the video on the next slide, or I can put it up also as a Google slide as well, and you can display that. It's really your choice. I don't really mind. Answers are also included. Here we go. So here is the main task for today. I'd like you to find the nth term of the following sequences. All right, there is 14 of them. We're looking at maybe 1 minute to 2 minutes per question. Don't worry if it takes you a little bit longer than that. Don't worry if you don't get all 14 of them done. The first 3 are definitely really, really nice, easy numbers, and then they do get a little bit more complicated after that. So they're going to be some amount of n squared plus or minus another number at the end. All right, I would say go ahead and work on those about 20 minutes or so, or at least until the end of the lesson. And then that is us done with our quadratic sequences for today. And there are the answers if we are still watching on the YouTube video. All right, enjoy. I'll see you later in the week. Bye.